problems on KVL and KCL. And as you know, KVL and KCL are most important for the whole subject, not only for electrical circuits but also for electronic circuits. So I am going to give lot of emphasis on this particular topic, KVL and KCL. If you see that, I am going to do almost 20 problems in this, because if you are good in this, rest of the subject is going to be easy. So let us concentrate on KVL and KCL. Another reason why the KVL and KCL is most important is, for objective exam, they can't ask bigger questions, but KVL and KCL is very simple questions. For example, if number of variables are 2 or 3, we go for mesh analysis. If the number of variables are 1 or 2 maximum, we'll go for KVL and KCL. So let's go to the first question. As the question is seen, the value of I in the circuit shown. So we have to calculate the value of E mentioned in the circuit and problem, and value of I in the problem. This is given in GATE 1997. It's for 2 marks. Of course, it is given for EEE. As you already know, networks is a subject common for EEE, ECE and instrumentation. And options are given like this: A 13 amperes 31 volts, B 12 amperes 21 volts, C 11 amperes and 11 volts, D 13 volts 31 amperes. Let us see how to really solve this. The question given is this. For example, this is the question given to us. If you see the problem there, what is given to you? This is another resistor and one more resistor is given here. In this data, he gave values as 1 ohm, 6 ohms, then 1 ohm. This current is given as 2 amperes. This is 4 ohms. And the last one is 1 ohm. And what are you supposed to calculate? You are supposed to calculate this voltage E and this current I. So if you calculate, how to calculate this now, please see the approach. I am doing the solution. If you treat it as a ground, because this is common for all, this ground is common for all, and always try to use what is the existing value. Whatever is known, we always go from known to unknown. What is known here? 2 amperes, 4 ohms. That means this voltage straight away we can say 8 volts, because 2 into 4, 8. So this is one node, this is another node. But because of the data available, this 8 volts have come, as achieved. And if you know this voltage, let us say this voltage is some V1. Okay. Now I am going to apply KCL, Kirchhoff's current law. Please observe how I do it. Whenever you apply KCL, normally we assume all currents leaving. When you say all currents leaving, so E1 minus E by 1 plus, okay, then V1 minus 8 by 1 plus E1 by 6 is equal to 0. This is the equation that you can really have. So think of this equation, E minus E by 1, because if current is leaving. I am not considering this current, I am considering all currents leaving. This is normal notation in all Kirchhoff's laws. V1 minus, actually this is not V1 by 6, it is actually V1 minus 0 by 6. This is called reference voltage, or some people call datum voltage, and it is taken as ground. Ground means neutral. And now here, if you see in this simple equation, the first equation, you have two unknowns, This is unknown, this is unknown. We can't solve two unknowns in a single equation. That's why we are going to go for different currents. Come on. This is 8 volts, 1 that means you will have 8 amperes. 8 volts by 1 is 8 amperes. Now, can you add this 2? If you add this 2, the entering current would be 2 plus 8 is equal to 10. When 2 plus 8 is becoming 10, then this current is also known to us. If this current is also known to us, the best thing that you can do is, you can always estimate this current. This is KCL at V1. Now I am going to estimate this one so that I can understand this current, this voltage as well as current. For that reason, what I am going to do is, this current I know, this current I know, this I don't know. So what I will do is, I will apply KVL. If I apply KVL, plus V1 minus 10 into 1, the drop here, minus 8. Therefore, V1 is 10 plus 8 is 18. Now keep this 18 here and solve for E. That's very simple. Now, if you really solve this one, 18 minus E plus 18 minus 8 plus the by 1 and 18 by 6 is equal to 0. In this equation, the value that is available is unknown is E. That E we have to solve for. And if you can take it, this you call it as 3 there. And 18 minus this is 10 here. So therefore, we can say 18 minus E plus 10 plus 3 is equal to 0. By this you can say E is equal to, that is 21 and 31. This is 31 volts. 31 volts. So this has come as 31 volts. Now it is very easy to understand how much is this. For example, this is 10 and this is, as we already said, this is 18. And 18 by 6 is 3. If this is 3 and this is 10, what would be this current? This should be 10 plus 3, therefore 13. Therefore, our answer is, voltage is 31 volts, current is 13. So, if you observe this, if you observe these values, you can say among ABCDs, current is 13, voltage is 31. Therefore, option is A. So, this is our answer for the solution or the given problem. Let's go to second problem, the value of R in the circuit shown. This is given in GATE 2004, that's also given for 2 marks and triple E. See, whenever 2 marks question is given, it is normally some calculation is involved. So, when calculation is involved, they give 2 marks. If it's a simply concept, they give 1 mark. Even if the calculation is simple, they give 1 mark. So, observe the weightage of the marks as I am going through my lecture. So, look at the circuit. The circuit is having a volt source is there, resistors are there, unknown resistor we need to calculate. The options given 10 ohms, 20 ohms, 30 ohms and 40 ohms. So, let me give you what exactly happening here. This is a voltage. To this voltage, 10 ohms is given. Another 10 ohms is also given here. Okay. Then they have given one resistor called R. And this is 100 volts. Okay. With this data, we have to calculate. We cannot really calculate R. For that, they gave one other hint. This is 2 amperes. So, observe the 2 amperes there. Now, I am going to calculate the value of resistor. For example, I will assume this as a ground there. And let me call this as some voltage called E. A nodal voltage is assumed. Then let me apply a KCL. KCL at E. Okay. How much is that? E minus 100 by 10 plus E by 10 plus 2 is equal to 0. As I said, all currents leaving. This current is leaving. For example, E minus 100 by 10, E minus 0 by 10 is equal to plus 2 because this is already leaving. Because in every equation, there should be one unknown. In this equation, the only unknown is here. You can say 10 is a LCM directly. When you say 10 is the LCM, so E minus 100 plus E plus 20 is equal to 0. Therefore, 2E is equal to, and look at this 2E, and you have 80 volts. So E is 80 by 2 is 40 volts. So when this is 40, now I need to estimate R. I can easily do that. For example, this is, what is the current in this? 2 ampere. E minus 0 by R. Therefore, this is 40 by R is equal to 2. And by that you can say, if you cancel this, 20 comes there. So answer is 20 ohms. So if you see A, B, C, D, the answer in this one option is B. B is the option, that is 20 ohms. Let's go to third problem. In the circuit shown, the power supplied by the voltage source is, because power will normally supply different sources, is asking for voltage source. That means among all this we have 10 volts. This is given GATE 2010, 2 marks for EC. EC means electronics and communication. The options given are 0 watts, 5 watts, 10 watts and 100 watts. So let us take this problem as circuit given and solve it slowly. This is a little bigger, that's why 2 marks are given. In fact, I wish they would give more than 2, because the maximum marks in the GATE exam is 2. So we can't expect more than that. So first thing that they are giving is the voltage is given to us, that is 10 volts. See, my normal style of writing or drawing is, I normally start for writing from source. If it is electrical circuits, I draw with respect to voltage source. If it is electronic circuit, I draw with respect to active device. So though this is given there, I will be drawing there. That's natural practice and should be better. It would be better even if everybody does it. Then he has given a resistor. Then he has given a current source. That's 2 amperes he said. Then he has given one current source here, 1 ampere there, 1 ampere. Then he has given one resistor here, one resistor here. This is connected back. Here also he has given one resistor and another resistor here. So look at the values. Luckily, easily to remember, he gave all 1 ohm, 1 ohm, 1 ohm, 1 ohm. And he is asking the power supplied by the source. So now let me slowly start. Let us say this is I. I is here. If I is entering, and you look at here, this I is here, 1 ampere is here, 2 amperes here, the total is 3 amperes, because 2 entering, 1 is leaving. Then how much would be this? 3 here and I there, so it is 3 plus I. That's a current. If 3 plus I is here, that's coming because they are in series. Series, there is no current division. Then there comes 1 here. If 1 is going there, you have 2 plus I here. And 2 plus I is here, 2 is here. How much will come back? I will come back. So that's the beauty of assumptions. So why I am doing all this is to understand. Finally, I want to say power is 10 into I. That's it. Because P is equal to VI. If P is equal to VI, what happening is, look at this 10 and I. In this process, all that we are required to solve is I. How to solve I? Very simple. Go for Kirchhoff's laws. You can easily solve what's happening. For example, I will be going for this loop. That's very easy. Loops can be taken anywhere. You can take a loop here. You can take a loop here. You can take a loop here. You can take a loop anywhere. So this is actually called a bigger loop. When you take more than one loop, we normally call it as super mesh, more than one. And let me go now. This is plus 10 going here, minus 3 plus I into 2, because 1 plus 1 is 2, minus 2 plus I into another 2 is equal to 0. Once again, plus 10, there's a drop here, 3 plus I into 2, 2 plus I into 2 back here. So the only unknown is I. You solve for I, and that I you substitute here. And therefore what happens is, so 10 minus 6 minus 2I minus 4 minus 2I. That's it. I'm just expanding. 6 minus 2I, 4 minus 2I, and in the process, will you please calculate it all together? This is 6 plus 4 is 10, 10 minus 10 is 0. That means 4I is equal to 0, I is equal to 0, therefore power is voltage into current 0, therefore 0 watts. Therefore, if you see the options given, option is 0 watts. So that's the answer for this problem called third problem, calculating the power supplied by the voltage source. Let's go to fourth problem. For the circuit given in the figure, the voltage V is, that's given gate 2000, EC 2 marks. The options are 2 volts, 1 volt, minus 1, none of this. None of this is also given. Please remember, normally sometimes you may get some other answer. That's why any other answer other than the ABC, that goes to none of the above. Look at the circuit here. This is the problem with active device. Whenever active devices are given in electrical circuits, don't be shocked. You simply go for equivalent circuit. After drawing the equivalent circuit, every electronic circuit becomes electrical circuit. That's why we always challenge people to study active devices or dependent source. A dependent source is nothing but active device. That's why we will solve this problem. Let's calculate the voltage V0 mentioned in the circuit. The circuit is given here. For example, it was given, the diode is given down, and then we have a resistor here, we have a resistor there, and you have sources here. One source is given positive, so put positive there. Another source is given positive, that means upper one is negative, or you can say both are positive here, then this is upper. So that's the meaning. When you look at here, values also let us take. This is 4 volts, this is 2 volts, and this is also 2 ohms. One is 2 ohms, another is also 2 ohms. And the rest of that which he is giving also 2. And this is called V0. And please, important thing is find out the polarity. So plus is here means negative is there. So that's the meaning. This is the problem given to you. How do you attack? For example, as I said, whenever there is active device, particularly diode, so easy to talk. Diode has only 2 options, on or off. So look at this 4 volts, 2 volts, both are equal. When voltages are equal and also resistance are different, same. What happens now? This will produce more, this will produce less. Ultimately, they will produce effectively some voltage. When it is producing voltage, what happens is, let us talk about this diode. Let's talk about the diode. To understand how diode, so this is given as a negative. And that's why I am asking you to really observe, it is 4, it is 2. What will happen? Effectively, how much is coming here? Is that negative coming? If negative is dominating, diode is off. If positive is dominating, diode is on. Very simple to talk. Positive is more here, that's why you can easily say without too much of calculation that this is on. If the diode is on, it's as good as short circuit. If it is short circuit, just like a wire. Now you just calculate, call this as some. This actually you can say this V0 is directly here. But instead we will do one thing. If you say this is V0 here, this is negative voltage, remember. Because as the polarity says it is minus, so let us say minus V0 is there. And now I am going to apply Kirchhoff's current law. As already said, all currents leaving. So let me say minus V0 there, minus 4, minus or plus we will say, then minus V0 by 2, then plus minus V0, minus of minus 2 will become plus 2 by 2 is equal to 0. For example, this is minus V0 minus by 2. Always very easy to understand. These two things are same, the LCM is same. So I can easily ignore that and say minus V0 minus 4 minus V0 minus V0 plus 2 is equal to 0. Now calculate how much is there. 3 E0. So minus 3 V0. Okay. And this is 2. This is minus 4 plus 2. How much it will become? It will become minus 2 effectively. Therefore, if you multiply with minus sign, as you know in mathematics, so this is 3 V0 is equal to minus 2. V0 is equal to minus 2 by 3. And now you see the options there. This is not available in the options, and hence the answer is none of the above. None of the above means answer is D. So this is how you can solve even if there is a diode. So I am going to show as much as possible dependent sources, AC sources and active devices at time. This is the solution for this problem. Let's go to fifth problem. In the circuit of the figure, we need to calculate the voltage E. It was GATE 2000, EC 1 mark. See, such a big problem as it seems to be, it's given for 1 mark, you can understand that it's going to be very small. Options given are minus 16, 4, minus 6, 16. Let us see what's going to be the correct answer. So look at this. Here is the problem. He is asking E. And then here is another source he has given. He has given 0 there. Okay. This is 1 volt. Then he has given another source. That source is 5 volts. 5. And you see here another thing given to us 10 volts. Okay. And then you have another one here 4 volts. Then he has not given anything. He simply said V2. And lastly he gave here V1. The voltage given is 2 volts. That's all. And all that he is asking for us is to calculate E. Now the best thing you need to understand, what is the best approach? Solving a problem in GATE exam is not a big issue. In fact, 50% of the students will solve problems. The question is how fast you solve, what shortcut you take, it all that matters. Let's see what happens there. Now I am going to ask you which loop is better. See, you can take this loop, say loop 1, and solve for E. Or you can take this loop, again that comes. And which one is better? Because first one is better because this voltage are given. If you take this loop, these two are unknowns. But the reality is you can still use this loop if you want, provided use here to estimate V2, use this loop to estimate V1, and then use this loop. 3 loops are there. What a laborious thing. So instead of using these 3 loops this side to achieve the E, let me go to directly here. When he says it is 0, it is ground. And when he says 10 volts, that means indirectly he is telling us 10 volts here. And this being ground and this being ground, you can just short it. Short it. And now you apply the KVL. I am doing the KVL now. Let me start over here. So let me say KVL I am going to apply for the first loop. Plus 10 plus 5 plus E plus 1 is equal to 0. Therefore, E is directly minus 16 volts. What a fast it has taken, one step answer. But if by mistake, if the student is really taking this approach, he will be applying KVL thrice, wasting his time. Time is more important than the answer here. So therefore, the answer is, according to the given options, answer is A. Let's go to sixth problem. The voltage V in the figure is equal to, is given in gate 197, EC 1 mark. The options are A 3 volts, B minus 3, C 5, D none of the above. Let us see what is the basic answer. So let me draw the figure and then slowly estimate the answer. For example, this is 5, he said 5 volts. Then he has voltage across this, it's called plus minus V. Okay. Then another source he gave 4 volts. Another voltage, another resistor he gave 2 ohms. And across this he gave another voltage source. This is 4 volts. Actually, this problem is very simple. It's unnecessarily creating a problem for this resistor. Just ignore this. Why? Because this voltage is same. You can just apply KVL. I am going to apply KVL, you see there? KVL is plus 4 minus 5 minus V is equal to 0. In fact, the value of resistor also doesn't matter. Let that be any value, it doesn't matter. And then V is equal to, this is 8, or we can say 8 minus 5 is equal to 3, and if so minus V plus 3, so V is equal to 3 volts and V is equal to 3 volts. So this is the option that we have. Therefore, our option is A. Let's go to seventh problem. The voltage across the terminal A and B in the figure shown. Gate 98, EC 1 mark. Options given are 0.5, 3 volts, 3.5 and 4 volts. Let me draw it and do this voltage between that. Start, as I said, start with voltage source, plus minus 1 volt here, resistor there, then you have 2 ohms here, 2 ohms there, then you have 3 amperes here, and the ohms are given is 1 ohm. This is A, this is B. It's a very simple problem. We need to calculate voltage between these two terminals. Very simply, you can do one thing. Call this as directly VAB, making this as a ground. Simply apply KCL, Kirchhoff's voltage law. For example, if I am applying KCL at VAB, as I already told you, VAB minus 1 volt by 2 plus VAB by 2 minus 3 is equal to 0. Why minus 3? Because this entering, leaving, entering. In the process, if you take LCM as usual, VAB minus 1 plus VAB minus 6. You know why did I say minus 6? Because I am taking LCM there. So this altogether you have 2AB is equal to 7. So VAB is equal to 7 by 2. So answer is 3.5 volts. 3.5 volts. That's the option we have. And the solution is, therefore option is, let's see the option there. Yes, C. C is the option given to us. This is a very simple solution. Like this, Kirchhoff's law gives you very small. 1 mark, easily you can achieve. Let's go to 8th problem. In the circuit shown below, the current through the inductor we need to calculate. It's the gate 12 for EEE 1 mark. Options are given 2 by 1 plus JA, minus 1 by 1 plus J, 1 by 1 plus J, 0. Actually, when you look at this problem, you will be shocked. You will wonder how much bigger problem is very big and we have to really solve it. But answer is, if you get an idea, it will be very simple. For example, let me draw it. He has given 2 voltage sources. And when he has given 2 voltage sources, and please observe in the question given, one is plus, minus, minus, plus. This is ground. Yes, he is not tell anything ground there, but I am going to tell you what's going to happen. Now, the second thing he gave was current source. Another one is current source. What a nice thing, you see. 2 voltage sources, 2 current sources. And everything is given as 1 angle 0, 1 angle 0. Okay. And when you see this, he gave inductor here. Second one, he gave resistor there. Third one, he gave capacitor here. And the fourth one, once again, is here. And everything he said 1, 1, 1. For example, resistor is 1 ohm. This is J1. This is minus J1. This is 1. In fact, he himself gave A, B, C, D. So this is the problem I have just taken as it is, and also this is also given 1 angle 0, 1 angle 0. If you see all this, one thing you observe there, he has given directly in J. As I have been telling, while you do Kirchhoff's laws directly in the first topic, you must be exposed to AC content. So we have seen dependent sources, we have seen active devices, we are going to see now AC circuits given. So even if AC circuits are given, we should understand, write it. In every topic we should study AC. But in BTech, normally people tell you, or you learn AC only as a last unit. That's the mismatching between the BTech and the gate learning here. So expectations of gate, you see, they are expecting all topics AC should be studied together. Now come on. Suppose you really want to solve everything, indirectly he is asking the current through this. If you want to solve, for example, if you take Kirchhoff's voltage, loop analysis, 4 loops. If you want to take nodal analysis, maybe 4 nodes, maybe if you take one as a ground, it will become 3 nodes. But 3 equations we can't solve for 1 mark. And 4 equations also we cannot solve for 1 mark. So we have to understand the shortcut here. The clue of the problem is this. For example, you see here, I am going to apply, start here and see here. How much is the voltage between these 2 points? I want to see. So, voltage between VBC is equal to, for example, from here. So, one thing is it minus 1 angle 0. This is plus 1 angle 0. Why minus? Minus 1 angle plus 1 angle. And if you, therefore, this is basically 0 volts. And hence, I am going to simply say this totally grounded. B is grounded, this is grounded, this is grounded. All are grounded because it is acting as 0 volts. So can I draw the equivalent for this? equivalent is going to be like this. For example, here is a current source, here is a resistor, here is an inductor. So simple. Such a big circuit I have brought into very simple circuit by just knowing and understanding that voltage is 0. And when you see this voltage 0, you can say now the current is 1 angle 0 here, 1 ohm here, J1 here. There is a current divider rule. What's the total current? He is asking current here. So therefore, this current is equal to total current by total impedance into opposite impedance. Therefore, 1 by 1 plus J. This is the answer. And when you look at the options, you can see the option is C. So this is how you need to really solve. What a simple idea, but generally for a student, it's not so easy. To understand this logic, it takes a long time. That's why rarely people may do, doesn't matter, but understand always shortcuts.